All right, so we've been talking about really one side of the equation, right? We've been talking about, only half of the puzzle. The other half of it, so we've got production on one side and we've got costs on the other side. And when we talk about costs, we have this weird term called isocost, right? Which sounds like it's like some distributor of food, right? But an isocost is just a combination of inputs that yield the same, that's where that iso is coming from, cost. So the same is where the iso prefixed is coming from. And so it's going to equal the same cost, and we already defined, we know that W is the wage rate, we know that L is the amount of labor employed, we know that R is the rental rate for capital, we know that K is the amount of capital employed. All of this equals some fixed cost. Rearranging this into slope-intercept form, which is such an ease of doing for us. We find that we get, so here I'll do it along with you guys. So we subtract WL, that cancels out. We end up with just RK left on this side, C minus WL. Then we divide everything by R. This R cancels out. We end up with K is equal to C over R minus WL over R. So we really do minus W over R times L. Why did I put it in this slope-intercept form with K on the left as my Y instead of L on the left as my Y? I heard it somewhere, because K is on the Y-axis. Very good, absolutely, because K is the thing, when we draw the graphs, right, it's on the Y-axis. So that's why we're putting it into slope-intercept form on the Y-axis. All right, let's talk a little bit about changes in our isocost. Changes in isocosts. So, for given input prices, what are our input prices represented by? What are the two algebraic variables we're using to represent our input prices? W and R, I heard them. Very good job, everybody. W and R for wages and rental rate, right? Those are the prices of the inputs for labor and for capital, right? This one is for labor and this one is for capital. Awesome. So for these input prices, isocosts.
What was R again?
R is the rental rate of capital. Isocosts that are farther from the origin are associated with higher costs. And changes in these input prices, which are what again? W and R, will change the slope of the isocost lines. So any questions on that? After reading it, should be pretty self-evident. So let's go ahead and do some graphs. So this is figure 5-6 in your text, which is on page 180, 150. And so this is going to be a straight line. Let's put our thinking caps on here. What is this intercept here? What is my y-intercept here? Capital over R, very good. And our x-intercept, capital over W. Excellent job, Bimo. Very good job. We have our equation line, which, when we have this equation line on here, the way that we get this, so we can get these a couple of different ways, right? We can just think about, well, if I have a fixed cost and I'm just getting all capital and what, 0 amount of labor, that's what it means when I'm on this, right? The origin point here is 0, 0. And so when I'm up here, that means that I'm only using capital and I'm using 0 labor. Then it's going to be just my total cost budget divided by the rental rate of capital. Over here, same kind of thing, but with labor, right? I'm using 0 amount of capital, and so it's just going to be my total cost budget divided by W. Now, it's also kind of easy for us to see, because the way that we get x or y intercepts is we put 0 in for the other term, right? So if we're getting the y-intercept, we put 0 in for the L, right? So this is going to be k equals c over r minus w over r times 0. 0 times w over r, that whole thing cancels out. We just end up with k equals c over r as our intercept, which is exactly what we end up as our intercept over here. And we could do a similar thing if we wanted to calculate algebraically the intercept for the x-axis, but why would we, since it's the exact same? All right. Any questions on setting up our isocost? What's the slope of this line? What's the slope of the line? Taranga? You can't figure out what the slope of the line is from the equation? Y equals mx plus b? You know what the b is. You know what the b is, it's c over r. So what's the m? Negative w over r. Negative w over r. So our slope is right here, and our intercept, so this is our b. If we wanted to put this in the y equals mx plus b. All right, 2 more graphs, then we're out of here. So what happens if all of a sudden I am going to be consuming more expensive? So what if I have greater costs? If I have greater costs, that's going to be a shift outwards in this isocost line. So C1 over L, and this is going to be C1 over R as the intercept up here. And so this is going to be the more expensive input bundle, and this will be the less expensive input bundle. So C1 is more dollars than C0. Questions on that? First part of figure 5.7.
Yeah, how did you got the C naught over L? Don't it be C naught over W?
Yes, thank you. Very good. Good catch. And so then the next part of this is talking about changes in prices. So if we've got C over W, they do superscript for some weird reason. W, O, and this is C over the rental rate. If there's an increase in the price, then that's going to rotate this line inwards to a new point, C divided by W to the 1. So a more expensive wage is going to have a inward pivot of the isocost curve, and it's going to pivot along the y-axis, and it's going to go clockwise. Higher wages makes a steeper line in a clockwise direction. All right, so